Hello everyone, my name is Jayin Bhuju and I'm going to show you my project on Fibonacci sequence in sunflowers. Let's begin by the Fibonacci numbers. It starts as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. So you're thinking these are random numbers, but in Fibonacci sequence, the numbers found are by adding up the two numbers before it. Let's give some examples. 1 plus 1 equals 2, as you can see here. 3 is found by adding 2 plus 1. 5 is found by adding 3 plus 2, and so on. Now let's talk about the history of this. The Italian mathematician Leonardo of Pisa, better known as Fibonacci from his discovery, found the Fibonacci sequence in the 13th century when he was doing research in rabbit reproduction. So here's one way to represent Fibonacci sequence. It's called a Fibonacci spiral diagram. Here's how it works. So it shows that you're adding 1 and 1 by the spiral goes through it first. 2, 3, 5, 8, 13, 21, and so on. Now let's talk about sunflowers. Here are some pictures of sunflowers, and this is about the seeds. Here are 3 questions I found in encountering the way since I'm doing this. Are sunflowers symmetrical? Yes, the seeds are symmetrical. The only difference is the seeds. Everything else is same. Are sunflower petals in Fibonacci number sequence? Yes, Fibonacci petals are always in there if you count these. Now, do sunflower seeds have Fibonacci spirals? Yes, sunflower seeds have 55 clockwise, 34 counterclockwise, 21 clockwise, and so on, including this 13 that's counterclockwise. Now let's talk about the golden ratio. The golden ratio can also be found in nature. The golden ratio exists when a line is divided into 2 parts, as you can see here, and the longer part, which is defined as A, and then divided by this shorter part, defined as B, is equal to the sum of A plus B divided by A equals to 1.618. Now, let's talk about an example. You need a door, and then what happens is you should pretend like B is the width, and then A is the length. If you add them both up, and then you divide it by the length, if that is 1.618, it is said to be more attractive than doors that are just random. Now let's talk about our last part, symmetry. Symmetry is like we find symmetry in nature everywhere, and we use the symmetrical form in our design, including buildings and architecture. Now let's talk about the types of symmetry. There's vertical line that goes up to down or down to up. Horizontal line, left to right or right to left. Diagonal line, it goes across the object. Thank you for listening to my presentation.